We'll try to record. They said that they fixed my computer. I don't know if they did or not, but anyway. All right. Go ahead and look at that problem there. And write it down. Well, that's not it. No. Write that problem down. Verify that the given equation is an identity. Now, when you're given one of these problems, they're going to ask you to verify. Does that mean you have to do both sides or just one side? Just one side. Now, you can pick which one you want, but this one isn't very nice no matter what. Go ahead and see if you can start writing in terms of cosine and sine, see if that'll help. Pick a side. I know you can write cotangent as something. See what you come up with. It should take about 3 minutes. Let me call her back. Things I do for y'all. Now, the bad thing about these problems is that sometimes you don't know which side to pick. But always go back to the old saying, try to put everything in terms of what? Sine and cosine. So it looks like to me that part of the right side is already in the form of what? Sine and cosine. So let's pull in our handy dandy identity sheet that all of you should have printed out by now. Let's go ahead and put it right there. And there's cosecant. Well, cosecant is equal to what? Right here. 1 over the what? It's equal to 1 over the sine. So you can take the cosecant and rewrite that as 1 over the sine. And yes, I forget the x's, and remember, I'm trying to teach you how to do the identities. I'm not trying to dot T's and cross I's. You can add the x's if you want to. Distribute, and you get cosine over sine plus sine over sine. And what's cosine over sine? Cosine over sine is what? Cotangent. And what's sine over sine? And that's how you do it. Now let's go the other way. See if you can verify. What is this? You have witnesses or what? What's going on down
Maybe it's bunch of people doing that kind of speech for that, but sounds a lot like we put it into one.
Our visitors have found out.
And it's all white males. They're racist. They're having a Ku Klux Klan meeting downstairs.
Oh, there's two black ones.
Oh, they are? Well, they're racist too.
No,
Because you can be a black white supremacist. That's what they call Sheriff Clark. And what's the other person they call a black white supremacist? Oh, the girl. What's the actress? The actress. She's a black actress and she's a conservative. She played in some movies. I mean, she's not a worldwide actress. She played in several movies. Can't think of her name, but she was called a black white supremacist. How can you be a black white supremacist? Anyway, go the other way. Take this side and prove this side. Why I erase this? And when I erase it, it's going to erase the whole thing, probably. Yep. Golly, what a surprise. Russians. I think it was this one, was it not? This one. There we go. The first thing I'm going to do is, let's see, I want to prove this. So the cotangent is equal to cosine over sine. And I'm going to write this as what? Sine over sine. Now, why did I pick sine? Because now I've got common what? Common denominators. Now I've got cosine plus sine over the sine. Okay? Now I can pull out the sine and I get 1 over the sine times cosine plus the sine. And what's 1 over the sine? So that's cosecant times cosine plus the sine. Now, you should be able to go either way. Y'all remember back in algebra where you learned shortcuts and you learned the shortcuts 1 through what is it, 1 through 5? Okay. But do you remember when the teacher told you that you have to learn them backwards and forwards? You have to learn them to where you know backwards and forwards. That is the way you're going to have to learn these things. You're going to have to learn them to where you can rewrite any identity into another identity. Okay? So you got to get good at them. So let's do a nerd. Let's go to the next page. Okay, rewrite this one. It says write tangent and cotangent in terms of sine and cosine. And you're going to see that a lot in terms of some kind of sine and cosine because that's what they're trying to get you to do. The old rule of write everything in terms of sine and cosine. So the tangent is equal to sine over what? Sine over cosine. cotangent is equal to cosine over sine. Common denominator is cosine sine. Cosine will go into cosine sine, sine times, that's sine squared. Sine will go into cosine sine cosine, that's plus cosine squared. And what's sine squared plus cosine squared? Well, where's your reciprocal identities? 1, so that's going to be 1 over cosine sine. Now, how do I know I'm finished? Well, what does the direction say? So I'm done. Now, the reason I didn't go from here is because this right here is another identity. How do you know that? Well, you know your identities. Right now, you should be good with this one, these, and these. Really, you're supposed to have these down to pat too, but those are not used very much, but these are. All right, let's go to the homework. And the reason I'm devoting a whole day to this, or a whole class period to this, is because it's important. All right, try that one. Remember, try to get everything in terms of sine and cosine. Shoot, I can't bring in pictures, can I? Nope, sure can't. So I need to sniff this out. Well, what do we got? We got fractions, right? So you got to have a common what? Denominator. Well, that cotangent is bothersome. So you could write cotangent squared as cosine squared over what? Sine squared. You could also write cotangent squared as 1 minus what? Or cosecant squared minus 1. You could do that. Either way, you're going to have a cluster no matter what, because of why? Because it's a mess. I would probably change, I don't know, change cosine squared to have a complex rational expression. I don't know. Probably. No, I'm not saying it's the right way, because there's 2 or 3 ways you can do these. Okay, it just disappeared. Okay. Go away. And now it's an eraser. What will it be before the end of the class? All right, cosine squared, we know that cotangent squared is equal to 1 minus cosecant, or cosecant squared minus 1, or cosine squared over sine squared. I like that. So 1 over cosine squared over sine squared. Minus secant over cosine squared. Cosine is what? Cosine is 1 over the secant. That's really not going to help us, so I'm just going to leave it as cosine right there. Cosine over 1. Now, write everything as a fraction. 1 over 1 over cosine over sine minus secant over 1 over cosine over 1.
Why is it 1 over 1 over cosine?
Well, what's 1 over 1?
Get rid of the square.
I'm making everything a fraction. I'm turning all these into fractions because of this fraction right here. Now, the common denominator is sine.
Does the cosine and sine still need to be squared?
Yeah, thank you. Cosine squared. Okay, so the common denominator is sine squared. So I can multiply through by sine squared, and that will, I don't think this is going to work. And you're going to find this out when you're doing these. Sometimes they don't work. Sine squared over 1 over sine squared over 1. And that's going to give you sine squared minus, what is the secant? The secant is 1 over the cosine. So you can change this to 1 over the cosine. That's not going to work either. So I'm just going to leave the secant sine squared over cosine squared minus sine squared cosine. Factor out a cosine on the bottom, factor out a sine squared on the top. I'm looking to see what happens here. And we get sine squared on top. That will leave us with 1 minus secant. And cosine on the bottom. That leaves us with cosine minus sine. And sine over the cosine is the tangent. So that's going to give us tangent sine over cosine times sine over 1. And 1 minus the secant over cosine minus the sine. And here we get tangent sine over cosine, so that's going to be tangent sine, sine tangent. 1 minus the secant over cosine minus the sine. Okay, so that's not good. So we know we've taken a wrong turn. So what do? We erase everything and try again. Let's see. First of all, we changed this cotangent right here, didn't we? Okay, so let's not change that. Let's go over here and change that secant. And make the common denominator, is that cotangent or cosine? That's cotangent, right? The cosine can be written as 1 over the secant. The cotangent can be written as 1 over the tangent. And it also can be written as the secant, cosecant squared minus 1. But I don't think that cosecant squared minus 1 is going to help us. So you might want to try rewriting that cotangent squared as 1 over the tangent squared. That might work. And 1 over the tangent squared, 1 over sine squared over cosine squared. That might work. Go ahead and try that. See what happens when you change that into 1 over the tangent squared. Try that. Now it's gone again. Now, do y'all also remember doing the reverse FOIL? Remember doing a reverse FOIL? Reverse FOIL, you can say it however you want to. Break up the first term, and then you have to find a combination to get the middle term. That method is called trial and what? We're going to be doing that quite a bit with these. Hold on a second, guys. I messed up. I mean, not y'all, Skype people. Hold on a second. Well, go ahead and work on it. With I reinstalled Skype today to see if it'll help my recording. I don't know if it does or not. Yeah, should back. Basically, what you're going to see there is you're going to see the same thing. You're going to be going in a circle. Okay? So, why not try to pull something out before we get started? Is this the problem? Yeah. But that's not the long whiteboard. So y'all can see it better. Let me just erase this. It's going to take it off. There.
I managed to get secant pulled to the bottom, but one had the secant square.
Okay. Well, what I'm fixing to show you might help. If I could work this thing and chew gum at the same time.
Getting better at it.
Yeah, but when you're thinking about 20 million things at one time, it's hard to do. All right. Why not pull something out? I don't know, maybe this cotangent. Bring this one out, maybe 1 over cotangent times 1 over cotangent. Put that parentheses minus 1 over cosine times secant. I don't know, it might help. Over 1. What's 1 over the cotangent? 1 over the cotangent is equal to what? Equal to the tangent. So you could actually write this as tangent. This is tangent times tangent would be tangent what? Tangent squared minus, what's 1 over the cosine? Secant, and that would be secant times what? That would be secant squared, so we would have tangent squared minus secant squared. Hey, wait a minute. What's that equal to? Tangent squared minus secant squared is equal to what? Be equal to -1. I think that's probably what they want you to do. It says simplify the result. That's probably the answer. Let's go back to the question and see. I don't know how far they want you to take it. It could be -1. Let's go back and see. Let's put -1 in and see. Probably wrong. No, that's right. So they want you to go down to -1. Next question. All right, try that one while I snip it out. Snip. Perform the indicated operations and simplify the results so that there are no what? Quotients. A squared plus B squared is equal to A plus B times A minus B. I don't know if that's the way you want to do that or not. Then you could say sine squared. There's 2 or 3 different ways you could do that. All right, work on that one. Now, 2 plus sine squared, that could be A plus B quantity squared. So you could actually go 4 plus 2 sine t plus sine squared of t plus cosine squared of t. What? Somebody's calling me? It's Pooh. She's not in here. I'm having class right now. You're disturbing my class. All right, bye-bye. All right, now they can't think. Students can't think. I'm going to try that. I don't know why. Just take that and see what happens. I don't know where's my... I'm just going to use the clear board and see what happens. So this is A plus B quantity squared, which is equal to A squared plus 2AB plus what? B squared. So I'm going to make that 4 plus 2 times 2 is 4 sine of t plus sine squared t plus cosine squared t. And I'm just saying, what's that? 1, 4 plus 4 sine of t plus 1, 5 plus 4 sine of t. Now, I don't know if that's what they want, but I don't see any quotients. Now, of course, if you don't know your shortcuts, you're going to suck at that. So you're going to have to learn your shortcuts again.
Is that the FOILing shortcut you're talking about?
Huh?
Is that the FOILing shortcut you're talking about?
Yeah. Well, reverse FOIL is when you do x squared plus 4x plus 4. And you break up x, let's see, 1 and 4, 2 and 2. 4 and 1 will give us a 5 or a 3. 2 and 2 will give us a 4 or a 0. We want 4, so it would be 2 and 2. This is positive, so the biggest number has to be positive since 2 and 2 is second. Just pick one. This means like signs, so this will be positive. So x plus 2 quantity squared. That's the reverse FOIL. Remember doing that? Okay, that's the reverse FOIL. The shortcuts are the 5 shortcuts. Did I go over those with you? The shortcuts, the 5 shortcuts.
No, I mean, you just mentioned those a few ago.
Okay. Well, I'll write them down for you right quick if I can find the whiteboard again. I'm on the clear board right now, so I'm looking for my. There it is. Let's go to the whiteboard. And I'll write down the 5 shortcuts for all you slackers. I'm sorry, for those students that don't remember them. A plus B quantity squared is equal to A squared plus 2AB plus B squared. A minus B quantity squared is equal to A squared minus 2AB plus B squared. A squared minus B squared is equal to A plus B times A minus B. A cubed plus B cubed is equal to A plus B times A squared plus minus AB plus B squared, and A cubed minus B cubed is equal to A minus B times A squared plus AB plus B squared. 1, 2, 3, 4, 5. I call them shortcuts 1 through 5. But all of you should remember them from college algebra. And hopefully you want one of those students, well, I can do it by the reverse FOIL method just as fast. Well, if you're one of those people and you didn't learn them, you're going to be sucking wind during calculus in this class. Okay, so let's see how I did on the answer. If I could ever find it. Let's get out of this. There we go. I'm just going to put a 5 in there. Yeah, I know 5's not the answer, y'all. What'd they get? God, it's a miracle. Now again, I was lucky that time. The reason I was lucky was because I kept looking at that first one. I kept looking, well, where'd it go? Did it disappear? Oh, right here. Is this it? Is this a different problem? Huh? It don't look the same. Okay. All right. I kept looking at this, and first of all, I thought it was this. Let's see if we can do it this way. Use shortcut number 3. This is a good test question. So I can find the forward. I don't have my head in the game today, y'all. Okay? Y'all haven't noticed. All right. All right, now I'm going to try this. This is what I first started to do. 2 plus sine squared. No, can't do shortcut number 4 because of that. Or shortcut number 3. I was going to do shortcut number 3, but that has to be a minus symbol, so it won't work any other way. You could do, well, it's already in the form of sine and cosine, so there's nothing really more you can do. All right, let's try another one. Please work with me. All right, try this one. Perform the indicated operation and simplify the result. Okay, this is good. This is a good question. There's something there you got to recognize. If you don't recognize it, then you can write that up as what? There we go. What should you recognize?
1 plus sine of x.
1 plus sine of 1 minus sine.
Exactly. Shortcut number 3, Hubert. That's right, class. Y'all are all winners. Number 3. So apply shortcut number 3 to this equation. Or this expression, sorry. This is a very important homework. 9.1 is kind of like the floor, not the floor, but the footing for your identities. If you don't know 9.1, if you can't do every one of 9.1 homework and not get it right, then you shouldn't go on to 9.2. So, 1 over 1 plus sine of x minus 1 minus sine of x. Basically, this is a plus b, and this is a minus b. So the common denominator is a plus b, a minus b. So I'm just going to write it. I'm going to write it out. You can use shortcut number 3, but I'm going to write it out. 1 over 1 over 1 plus sine minus 1 over 1 minus sine. Well, I'm going to put the common denominator down here. It's 1 plus the sine times 1 minus the sine. There's the common denominator, which is 1 minus sine squared. And we'll write that in just a minute, not right now. How many times will this denominator go into this denominator?
1 minus sine.
Thank you. 1 minus sine times 1 is 1 times 1 minus sine. Now the reason I do that, if this was a 2, you would be distributing what? A 2. So you always need to put whatever's up here, you need to put it right there so you remember to multiply. Now since it's a 1, it doesn't matter. This negative 1 will matter. So I'm going to go ahead and put something right here. How many times will 1 minus the sign go into this? 1 plus sign. Now you've got an algebra problem. Finish. Distribute the 1 and the negative 1. Change that bottom to 1 minus sine squared. Okay, distribute that 1. And at -1, you get 1 minus sine minus 1 minus sine over 1 squared minus sine squared. And of course, what happens to the 1s? They cancel. And you get minus what? You're so smart. -2 sine over what? 1 minus sine squared. Now which one is that? Well, what's 1 minus sine squared? Cosine squared. So I believe it would be D. Y'all check it. So let's check it. Good job. I feel good about myself, so I don't have to put smokestacks on my truck. All right, let's do another one. Oh yeah, I'd quit on this one. I wouldn't even do it. Why? It looks too what? Looks too complicated, so just go on to the next one. All right. I don't know. You could probably distribute that cosecant if you wanted to. But let's think of the old thing of what? Get everything in terms of what? Sine and cosine. Try that. See what happens. Now also look at what they're asking. It says, which of the following shows the key steps, the key steps in establishing the identity?
I think they distribute it first and then they establish the identity.
Yeah, that's what okay. Yeah, they're distributing. Okay. So that'd be cosecant minus cosecant, cosecant, cosquared. Cosine is equal to 1. All right, so cosecant squared, cotangent. No, not cotangent. Cosecant squared. Nope, it's not the first two. I believe what they're doing, a squared minus b squared. I believe they're changing this into 1 plus I'm thinking, just chill. Cosecant, if I distribute that, that'd be cosecant minus cosecant cosine. See, there is nothing like that.
There's the second one.
Cosecant squared minus cosine, okay, you're right. Okay. So I would believe it would be C.
How do they get the cosecant, cosquared, and cotangent? I'm looking at my abilities. I'm not sure.
They're factoring out a cosecant. No, let's see. Cosecant squared. Put cosecant in terms of sine. What's the cosecant? 1 over the sine? That'd be 1 over sine squared. That's where it comes from. That's how they're doing it. We'll do the whole thing. Let's go ahead and do it. All right, so I'm not going to look at all this trash. Just right here confuses me. So cosecant squared, 1 minus cosine squared is equal to 1. Distribute, you get cosecant squared minus cosecant cosine squared, and that's equal to 1. Cosecant squared is equal to 1 over sine squared, sine squared, and what's the cosine? Cosine, well, cosine, you do cosine squared over 1 like that, equals 1, and then cosecant squared minus, well, this 1 over the sine squared, that's cosine squared over sine squared, and what's cosine over sine squared? Huh? There. I can do it a whole lot better that way than looking at all that. So it should be C. Okay, now this problem,
That was actually not as hard as it looked.
I would rather you just ignore all this. If I gave you this on the test, it'd be do this. Ignore this, because this confuses you. Confused me. Good job. All right, so here's one. This is a good test question because it's just asking you to solve it. All right, so do that one. And I'm going to snip it because I'm going to bring in the, the identities, because you might need to see them. Maybe I need to print y'all out some since it's so much work. What do y'all think? So much work, print button, have to print. I don't know why I asked y'all to do so much. Next, bring in clowns. Bring in problem. Okay, the first thing that hits me right off the bat is what? The -1 plus secant squared. You could easily write that as secant squared minus 1. So take that up to the Pythagoreans and see if that dang old secant squared minus 1 is equal to what? Tangent squared. So see, this one is not very difficult at all. But you look at it and you think, oh my God, I can't do that. And get that ditch ready. Secant squared minus 1 over tangent, and that's going to be tangent squared over tangent, which is equal to tangent. So tangent in that problem, let's look and see. Get back to it. E. Okay, let's ignore this down here and let's just go to the top. Let's write that down. Now, this is an equation where you have to establish identity. So that means I need to make the left look like the right or the right look like the left, don't I? I need to validate. So pick a side. I see shortcut number 2. Where do you see shortcut number 2? On the right side. So that's something you could do. I'm trying to think. You could rewrite secant as what? 1 over cosine, and tangent over what? Sine over cosine? That would be a cluster. Looks like to me shortcut number 2 might help you. I don't know. Let's see what happens when we try it. This is going to be secant squared minus 2 secant tangent plus tangent squared. That don't look too promising. We could rewrite everything. Secant is 1 over cosine. 1 over cosine squared minus 2. Secant is 1 over cosine. Tangent is sine over what? Cosine. Tangent is what? 1 over cotangent. So that's going to give us 1 over cosine squared minus 2 sine over what? Cosine squared. Oh my gosh. Plus 1 over what? Now at this point, what are you saying to yourself? I've done something right. Why?
Because you can cancel.
Why do you say you've done something right at this point? Well, no, the denominators, you would be the same. That's right, class.
How did you get tan squared to 1 over cosine?
It's sine.
Tan right here. Oh, this is cotangent. Get out of here, Logan. Well, we aren't doing everything right. 1 over cotangent. That's a prime example of you wanting to make something fit. I wanted that to be cosine. So now we've got 1 over cosine squared minus 2 sine over cosine squared plus 1 over cotangent squared. And I tell you right now, this doesn't look good now. Now, this right here will give us 1 minus 2 sine over cosine squared plus 1 over cotangent squared. Gotta do it again. And that doesn't look good. So we need to start over. So doing shortcut number 2 does not work. So that means probably you need to try to change this into sine and what? Cosine. Try that. That might help you. No, there's no ouch on. So secant would be what? 1 over cosine? And tangent is sine over cosine? That would be a total cluster. That's going to give you 1 over cosine squared minus 2 sine. Well, that's what we got. That's what we got over there, isn't it?
Yep.
Plus sine over cosine squared. Wait a minute.
Except for that last one.
That last one may change things. Where?
Where it's one over goes minus sign goes between that one minus sign over goes.
I'm sorry, are you talking about in here, or are you talking about up here?
Yeah, right there. So is that coming down and there's two together?
Oh, I see what you're saying, yeah. Thank you. I didn't even see that. Thank you. You could do that, you could make but also, so we're gonna try that other thing we were doing also. This is 1 equal to 1 minus the sine over cosine. Is that what you're talking about?
Yeah.
Squared. But that gives you the top, but you don't have the bottom. Cosine squared is equal to 1 minus sine squared.
Yep, and that's one.
And now we got the opposite. So let's look at that. So we got, well, up here we're going to have equals 1 minus sine quantity squared over cosine squared. And that's equal to 1 minus what? 1 minus sine squared. And then this is going to be 1 plus, no, it's going to be 1 plus 2 sine, be a minus 2 sine plus sine squared. Yeah, it's not working. But we do have the 1 minus. Okay, we've got the 1. We're getting there. 1 minus sine squared. I want to go back up here. That would give me, I'm just going to try this. 1 over cosine squared minus 2 sine over cosine plus sine squared over cosine squared. I don't know if that's going to help us or not. I'm just playing right now. We're moving along somewhere right here. But heck, we may want to try to change this into something because it doesn't look like it's working out.
Based on those bottles, that's something that we use in cosine squared.
Yeah, but I'm trying to figure out how we get the signs to change. Use the, no, that's not even going to work. You get the 1 plus the sign, I can
You
get
can
the 1
change
plus the
the
sign.
cosine squared equal
What are you talking about?
for the.
Right here?
No, up top where you just wrote.
Oh, up there?
The cosine squares would all equal, is it 1 minus sine squared?
Gets common denominator. So in other words, equals 1 over cosine squared plus sine squared over cosine squared minus 2 sine over cosine. And that's going to give us 1 plus the sine over cosine squared. 1 plus sine over cosine squared.
Which is 1 minus sine.
Okay, hold on. Let me finish doing what I'm doing. 2 sine. Okay, now we can get a common denominator. Is that what you're talking about? Get a common denominator of cosine squared, and that's going to be 1 plus sine over cosine squared minus 2 sine cosine squared times cosine squared cosine. So that's going to give us like I said, sometimes these things you can get 1 or 2 steps. Sometimes you got to trial and error 2 or 3 times. But most of you will probably what? Give up. So that's 1 plus the sine minus 2 sine cosine over cosine squared. And that doesn't help us one bit. They don't even give us, well, we could say the cosine squared is equal to what? The Pythagorean, the sine squared minus 1? Okay, whatever you, yeah, cosine plus sine. Cosine would be 1 minus sine. So that'd be 1 minus sine squared on the bottom. And up here, 1 minus 2 sine cosine plus a sine. That's not going to work. That's not going to do anything. Okay, so that means we need to try the other side. Well, I picked one. Well, it's just the homework, it's trial and error. Okay, let me just do this, start over. And let's pull the problem in again and start at the top. Anybody got a thing of feedback before we go to the left side? We're going to have to try to go to the left side because it's not cooperating with us. I'm going to pull the identities in also. You may be able to use a different identity. Let's see.
Are we supposed to be doing?
Okay, before we tried to prove this is equal to this, but now you do sine over sine minus sine over 1. You do that. Let's try that. But the sine is going to be equal to 1 over the cosecant. So that'd be 1 I'm just going to try something. Cosecant over cosecant minus 1 over the cosecant over cosecant plus cosecant plus 1 over cosecant. That's not really going to help. That'll give us cosecant minus 1 over cosecant over cosecant plus 1 over cosecant multiply by cosecant over 1 plus the cosecant. The cosecants cancel. You're left with cosecant minus 1 over 1 plus, or cosecant plus 1, right? Yeah. Cosecant plus 1. So that don't even work because we don't even have a square.
Did we check to see if they asked us if it was, is there anything else in the identity? Or if there's an option to say
Oh, I don't
if it
know.
is identical?
I don't know. Let's look at the question and see. I'm not the best on directions anyway. Then we'll look. Okay. All right. Here they're using this as we first started. So secant tangent will give us they're using shortcut number 2, like I did. I must have messed something up.
If there's the second B and D,
B and D is one of the answers, yes, because you can't do A and B. A and B is not correct. So they're doing shortcut number. Let me try it again. Maybe I did something wrong. So about ready to quit today.
it's 12:22 right now.
Okay. Well, chances are it's not recording right anyway, so let me go ahead and try to set up this last. I thought I was right by doing the shortcut, but evidently I didn't do something right. All right, let's try it again. Secant squared minus 2 secant tan plus tan squared. Okay, let's write the secant. The secant is equal to the what? 1 over the cosine. So that's 1 over the cosine squared of x. Let me do it. Okay, that's fine. Minus 2, 1 over the cosine. And the tangent is cosine over what? Sine. I'm sorry. Sine over cosine. Right? And this is sine squared over cosine squared. All right, check it. So that'd be 1 over cosine squared minus 2 sine over cosine what? Well, I thought
you did 1 over cotangent on the first one.
Well, I turned something into something it didn't need to be. Maybe that's what I did. So I had the right idea the first time. I just used the wrong identity. There. That's what you're supposed to come up with. Now, that's going to give you 1 minus 2 sine plus sine. That's going to, yes, that'll work. And I'm going to finish right there. Finish with this. You got a common denominator. Now you can make the top equal to something and the bottom equal to something. Whew, I began to think I was going crazy there for a moment. You said I turned this into 1 over the cotangent. That's where I messed up. Well, I knew I was supposed to get a common denominator. I wondered what happened there. Okay. All right, let's see if this thing's going to record after they fixed it. Where is my Skype?